Hello, this is Geometry, Lesson 5, 6, Inequalities in One Triangle. So our objective for this lesson is that you will be able to use inequalities involving angles and sides of triangles. This is going to be the first half of the notes. It won't be the entire thing, so we're just going to kind of go through a little bit to shorten the next day. So basically your central understanding for this lesson is that the angles and sides of a triangle have relationships that involve inequalities. So before we can really get into those angle relationships, we just have to review some inequality stuff. So there's this property here you need to put in the name. It's called the comparison property of inequality. It says if A equals B plus C and C is greater than 0, A is greater than B. So essentially what this inequality is saying is that if two things add up to one thing, the one is bigger than either of the two that add up to it. So for example, 10 equals 6 plus 4. Well, because 6 and 4 both add up to 10, 10 is bigger than 6 and 10 is bigger than 4. That's what this inequality theorem is saying, or property is saying, which should be kind of common sense. So we're just going to quick do the proof of this so that we can use it in context of triangles here. So it says, proof of the comparison inequality, given that A equals B plus C and C is greater than 0, prove A is greater than B. So first off, C is greater than 0. That's our first one. We can see that I gave you all the statements. We're just filling in the reasons. C is greater than 0. 0 came from our given statement, so we're just going to put given there. Notice it didn't put the other half of the given, so that's going to show up somewhere in our proof. Now here they say that B plus C is greater than B plus 0. This is a property that maybe you don't remember, so I'm going to give this one to you. It's called the addition property of inequality. Basically, if you add something that's not 0 to a number and you know that that something's bigger than 0, you're going to end up with something greater. So this is the addition property of inequality. Okay, well then because of that, B plus C is greater than B. That's the identity property allows you, so here's some properties you may not remember, but the identity property allows you to say, well, something plus 0 is just that something. So that's kind of the change that's occurring there. That's something you'll talk about more in Algebra 2. And now they jump down to say that this A equals B plus C. Well, if you remember, there was a part of our given that we never used. This line 4, that's the part of our given we never used, so we can say that was given. And we're almost done with our proof now, so now they just say A is greater than B. So here's where some of your geometry knowledge is finally going to come into play. What I would notice is they've talked about two different things. Here's an inequality, here's an equation. So my guess is they're somehow going to do some type of connection there. So I know A is greater than B, and if you look at the first inequality, first line in number 3, there's an inequality and it says greater than B. So they're probably doing something with that. But in step 5, it switches from saying B plus C to saying A. Well, that's where your step 4 comes into play, because since A equals B plus C, you can replace B plus C with A and say, well, then A is greater than B, which they do in line 5. When you replace something like that using the equation, see if you remember that property. It's the substitution property of equality. All right, so just a little proof reminder, they do exist. We will be doing some a little bit in the next chapter as well. So why this all matters is this next theorem. It's called the triangle exterior angle theorem. It says the measure of each exterior angle of a triangle equals the sum of the measure of its two remote interiors. This is something we've talked about before. It's in here as a refresher for you. Okay, so we talked about this before. These two angles, 2 and 3, they're remote interior to 1 because they're inside the triangle and they're not adjacent. So they add up to make 1. And the reason why we proved it a long time ago, it has to do with some 180 relationships in a triangle and in a straight line. So what we're going to talk about next is actually the corollary to this that says, well, because up there I said 1 equals 2 plus 3, that would then imply that 1 is greater than 2 and 1 is greater than 3 because they add up to them. So that's where that property of that comparison property of inequalities we talked about in the beginning comes into play. So because here they said 2 and 3 add up to 1, then 1 has to be bigger than 2 and 1 has to be bigger than 3. So we apply that in triangles to kind of figure out measurements. So I'm going to do the first one with you and I'll have you guys try the next one. It says, explain why the measure of angle 1 is greater than the measure of angle 2. So first off, let's find these in our picture. Angle 1 I see is right here, and angle 2 I see is right there. Now the first thing that I notice is that angle 2 is inside the triangle and angle 1 is outside the triangle. So a lot of our explanation for this, I just do a lot of kind of mathematical equations and just kind of use those to write my explanation. And if we think about the triangle exterior angle theorem we just discussed, well, because 1 is exterior, it's equal to the sum of its remote interiors. Remote interior angles are angles that are not adjacent to 1. So you can't use 4, that's adjacent to angle 1. So the remote interiors to 1 will be 2 and 3, which means that the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3 by the triangle exterior angle theorem, right? Well, we can say, well, because 1 equals 2 plus 3, then 1 has to be bigger than 2 because it's the sum of it, okay? So then we can say that the measure of angle 1 has to be greater than the measure of angle 2 by the corollary to the triangle exterior angle theorem. Okay, so we use the triangle exterior angle theorem to say, hey, 1 equals 2 plus 3. Then, because 1 equals 2 plus 3, 1 has to be bigger than 2 by our corollary to the triangle exterior angle theorem. All right, I'm going to just shrink this all down here a little bit so we can talk about this next one. Group. There we go. Okay, so on this next one, they're going to ask you to do a similar work around here. We've got angle 1 and angle 2. So first off, you want to notice where those angles are located. So I notice angle 1 right here. That's exterior. Oops, I'm going to make that green to go with the directions. And I notice angle 2 out here. Now there's a lot going on in this picture, and you might notice that first off, angle 1 and 2 are both outside the triangle, which means you can't just use your triangle exterior angle theorem. There's something else going on. So the other thing that I notice is that this triangle is in between parallel lines marked here and here. And anytime you see parallel lines, you want to think about all those angle relationships from way back in chapter 3. Alternate interior, alternate exterior, corresponding, etc. Okay, and so I notice that there is a pair of alternate interior angles going on over on the left side between 2 and 3, which is going to be important to us. So what I might just start by saying is that the measure of angle 2 equals the measure of angle 3 by the alternate interior angle theorem, right? Okay, well, 2 is not truly an exterior angle of the triangle because it's made by a side of the triangle and then this parallel line. And this parallel line here is not an extension of that side there. So it's not an exterior angle. So there's no triangle exterior angle theorem we can use for that one. But if we go down to angle 1 is made by a side of the triangle, an extension of a side. We can use the triangle exterior angle theorem with angle 1. So I notice its remote interiors are 4 and 3. So I can say the measure of angle 1 equals the measure of angle 4 plus the measure of angle 3. Slide that over, by the triangle exterior angle theorem. Well, my whole goal eventually is to relate 1 and 2, so if I can get them in the same equation, I might be good to go. And I know that I said in the first line that 2 is equal to 3, and here I use a 3, so what I might do then is replace 3 with 2, and now I would say the measure of angle 1 equals the measure of angle 4 plus the measure of angle 2 by substitution. And now I said, hey, 1 equals 4 plus 2. Well, I can then use my idea of the comparison property of inequality, the thing we talked about at the very beginning. Oops, wrong slide. The thing we talked about right here on the very first slide, where if 2 things add up to 1, the 1 is greater, to then say that 1 has to be greater than 2. So I go back to where I was. I can now say that the measure of angle 1 is greater than the measure of angle 2 by the comparison property of inequality. Okay? So that's kind of what they're doing. And what they want you to start to see is just those relationships that are going on in your picture like that. I'm going to have you guys pause the video and try one of these on your own. So there's one up here. It says, why is the measure of angle 2 greater than the measure of angle 3? So maybe you don't write it all out the way that I did, basically like a proof. Maybe you can just write out a bunch of the left side of those statements of angle relationships that you see and kind of piece stuff together. That's okay. So why don't you try this one on your own and then you'll check your stuff with mine. All right, here's everything I saw going on here. I first started by noticing that angle 1 was an exterior angle, and its remote interiors, you can see with my green arrows, are 3 and 4. So I said 1 equals 3 plus 4. The next thing I said, well, I haven't used angle 2 yet. And if you look at triangle CBD over here, this is an isosceles triangle right here. So I said, hey, 1 and 2 are the same in blue. Well, then I noticed that there was a 1 up in the first equation, and since 1 or 2 are the same, I could take that 2 and I could replace 1 with it. That's where my black line came from. And then in the black line, I noticed that I had an angle 2 on one side and then it equaled 3 plus 4. So because it's one thing and equals the sum of the others, 2 has to be greater than 3. So that's kind of the relationship I saw as I went around in that. All right, we're just gonna do a little bit more in the notes before we quit this video. So let's try this next one. It says, if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So basically this theorem doesn't necessarily have a name, it's just a relationship. It says across from the larger angle is the larger side. So larger angle lies opposite the longer side. So here they said XZ was bigger, across from XZ is Y. That means angle Y is bigger. Okay? So basically, we're just kind of asking you to recognize what's larger, what's smaller. I'll do the first one with you. We're looking at the first one. There's 3 sides, 2.9, 3, and 3.1. The smallest of those 3 numbers is 2.9. So that means AC is the smallest side, which means the smallest angle, we're listing them from order from smallest to largest, is across from the 2.9. That's going to be angle B. So we would say angle B. Now we look at what's left. There's a 3 and a 3.1. Well, 3 is smaller, so here's the 3 side. Across from it then is the smallest angle. Angle A is next, which would leave our last angle to be across from side AB, and that would be angle C. Now, some of them get into equations with you to remind you of some of this algebra relationships you might have forgotten, like this next one. It says 4y, 5y, and 3y. So you just want to think about the fact that all of those have the same variable in them and they just have a different coefficient in front of it. Well, you want to think about what's happening between the variable, like 3, and the coefficient 3 and the variable y. Well, there's multiplication going on there. So what's smaller, multiplying by 3, 4, or 5? Hopefully you thought 3. So that would imply that this side, KL, is the smallest side, which across from it is angle J. We keep going with that. Okay, well 4y and 5y is what I'm left with. Multiplying by 4 is smaller, so across from it is, I think that's an L, which would leave us for our last one being angle K. Now that should make sense on this one because you have a right triangle, and you know that in a right triangle, the longest side is this hypotenuse, which would imply that the largest angle in a right triangle is the 90-degree angle always, which might help you with some of these next two. So why don't you try these next two and then we'll check our answers and be done. All right, you can check your final answers on those with mine for C and D. For C, I said it was Z, X, then Y, and on D, I said it was Q, S, then R. All right, that's where we're going to stop on the notes for now. Thank you for listening.